Your host, Chris Harbert, and I'm here today with Adam England. Adam England has been the CTO or VP of engineering for multiple startups, including companies like Homebase, Storable, Noda, Red Nova Lab. Today, we're going to talk to Adam about why developers should know how to test.
Hey, Chris, thanks for having me.
Cool. So I rattled off a long list of companies where you've been involved from the very early stages, helping them get in place their tech teams, hiring developers. And I guess where I'd like to start with is, why is it that you think developers either should or shouldn't know how to test?
So, my perspective on that comes from really two angles. So I'll start with the money angle, right? I work as a tech executive, and at some point you're responsible for actually making these things cost effective. So if I'm trying to convince the CEO of a company or investors in a company why they should care about having their developers test, it all comes back to the concept of shifting left on quality. The research is in. We know that shifting left is a great way to save money on your development. The research out there shows, it's really almost an order of magnitude. A defect that costs $100 to fix in the coding stage costs $1,000 to fix in the QA stage and costs $10,000 to fix once it's found by a customer in production. So financially, you really can't afford not to have your developers doing their testing. The best way to shift left on that is having developers who can both write unit tests and end-to-end tests and catch those bugs, as early in the process as possible. So that's really succinctly why anyone who's in this business to actually stay in business needs to be having their developers do testing. If I'm talking to a developer who says, well, I don't care about that, I'm not in charge of the money, I can still give them a different reason. And it really boils down to, you're going to have more fun as a developer when you learn how to test effectively. I think back to myself as a 22-year-old dev. About the worst feeling in the world is when you think you're done with something, you ship it out, you start working on your next task, you're programming, it's fun, and then QA tells you that your stuff doesn't work. Now you have to task switch, you have to go back and work on something that you already thought was done. It's very demoralizing, and in the worst case, for a lot of developers, it's embarrassing. Being told that what you did is not any good isn't a good feeling for anyone. So how do you avoid having that bad thing happen to you? Well, you learn how to test. If you're writing unit tests, if you're writing end-to-end tests, if you're testing things on your own machine before you ship it to QA, you are not going to be embarrassed, and frankly, you're going to look like a better programmer than you really might be, and who doesn't want that?
Or do you want to be on call and fixing production issues in the middle of the night, right? I think given the option between the two, most folks would choose testing. So it brings up an interesting point. So this is the Developers Who Test podcast, but there are also a lot of testers who are developers in their own right. They're in more of a dedicated role, typically called an SDET, SDET, for software development engineer and test. So some companies have those as a combined role. Some of them have it as a separate role. And it's a real hot topic these days and a bit of a debate. Like, what's your position on what's a better model? Or maybe why might you choose one model versus the other?
Yeah, that's a great question. And it's really hard. Depending on what organization you have, different models make sense. If you already have some in-house talent that's used to doing things one way, then maybe converting that over to a different way doesn't make sense. But if I'm coming at this from scratch, I'm really viewing the SDETs as no different from any software engineer in the company, except that they are doing a different kind of code, right? So we're not splitting them up into concepts of, okay, these people are building test infrastructure and these people are writing the tests. We're really applying a DevOps mentality to our testing group as well. So we're saying your job is to deliver functional tests. And part of that is writing tests, part of that is setting up infrastructure, part of that is setting up the frameworks, and we're viewing those test engineers as, really kind of a grouping together. That's honestly my preferred term for that group, is test engineers. They're building the whole life cycle. They're not just writing requirements. They're actually building a full solution to bring everything together into one cohesive unit. So I try to avoid dividing up my SDETs and software developers too much and rather look at them as all software engineers who just happen to be writing different kinds of code.
Developer, an API developer, but then it's like, wait, you're a test developer? And that's somehow different all of a sudden. And I think it stems from writing the UI was manual or writing the API was manual, and it's now automated. And so I think that's part of maybe why the question comes in, are these folks really developers or not? And I think that's an important distinction to make.
Chris, I think you're going to see the same pattern that's happened there. I'm seeing generally the commonality of front end versus back end developers is reducing. You're seeing more and more of those job roles collapsing into just a full stack developer concept. We still have a couple outliers. We still have mobile developers are still considered their own special thing. Test engineers are considered their own special thing oftentimes. But over the next 10 years, I think you're going to see more consolidation and, for example, coming out and saying, I'm a full stack engineer, but I don't know how to do mobile, or I'm a full stack engineer, but I don't know how to write a test. People just look at you and say, well, then you're not a full stack engineer. So my prediction and my hope is that those specialized roles continue decreasing. And we just look at people as software engineers who do different tasks depending on the role they're needed for at that time.
Yeah, I think it might depend some on the size of the company, because one thing I've seen is, it's the classic balance between generalization and specialization, right? So generalized means you have one person responsible for everything. Specialized means you have different people responsible for different, more specialized tasks. And what I've seen is if you go into the everybody's a specialist route, in that area, and are they throwing work items over the fence to each other? And so it's harder to plan work, it's harder to schedule work, it's harder to balance your teams. The other side of that, you've got generalists, where I think you're right that the industry is definitely moving more in that direction. What I do fear a little bit is, I've been in environments where everybody's a generalist and everybody's responsible for everything, and then it means there are these certain unsolved problems that's not really anybody's job to solve, right? So when you have somebody who specializes in quality, sure, they're a developer, but their job might be also to focus on, are the tests running quickly and efficiently? Are the systems that are running those tests able to scale? And so I view it as not so much, maybe specialized versus, so like, just like you might have everybody be full stack engineers, but there's that one person on the team who's like the expert in Ember.js that knows it in and out and pays attention to what's going on the project. You might have another full stack engineer who's the Cypress expert or the Selenium expert, and that's their contribution to the team, is they're just specializing a little more in one of those areas.
I think one of the tricks I always try to use when managing teams like that, it's great to have specialization of your role, to know my role on the team is to be the, Ember.js specialist, or my role on the team is to be the Cypress specialist. And that's really helpful and really healthy for a team. It's when you turn that into a job title that it becomes a problem. When you tell somebody that their title is, Ember.js guru, now they don't feel like they can evolve or do new things or go outside of their realm. So I think a good manager needs to make it clear to people what their role on the team is, but give them a title that allows them to evolve and grow over time. So some of it's semantics, but it does matter.
Yeah, that's actually a really interesting point. A lot of times we think of a job title as being something that enables us to do more, right? Like, oh, if I just have that particular job title, that'll mean I'm in charge, or that'll mean I get to do X, Y, or Z, or that'll mean I make a certain amount of money. So we think of it as the title is giving us something. Haven't thought too much about how a title can actually be very limiting. So because I want to go write database queries, and can I have access to the API because I want to contribute to the API? It's actually very limiting to have too narrow of a job title.
Yeah, I mean, and that's especially true for companies that are going into test automation initiatives. It's not uncommon for there to be a lot of fear around that among staff. If your job is, QA analyst, then you may be worried that automation is going to threaten your job. And the way you look at that is saying, hey, your title is still QA analyst. Your job is still to assure quality on our product. You're just going to do that with a different set of tools. We're not going to give you a job title of, manual tester, because that implies that you will only do that and won't evolve into this new technology stack that's going to make you more productive at your job. So, by keeping those titles at kind of a general level and, letting people evolve their role, I think you get a healthier team with less fear that changes in technology stacks need to threaten someone's, value to the company.
Mm-hmm. Yeah. So let's say you're on more of the test engineering side. What advice would you have for somebody on that side who wants to get more involved in the development side of the house?
A lot of the job skills are similar, right? You're writing code. It's one reason why I think it's valuable for a lot of teams when they're going into automation to write their tests in the same language as their code is written and as their product is in. Because that's going to allow your folks who are in test engineering roles to already know the language and be able to kind of cross-train into developing on the product itself. They're coming with some certain strengths. They have great knowledge of the product. And if you can also have your test in the same language as the code, now they've got some of those chops in the language you're developing in. Similarly, the other side goes that way. If you have a developer who is interested in doing some more, testing, they already know the language that the end-to-end tests are written in, and they can jump back and forth with that, very quickly. I kind of always tell developers moving from a software engineering role into a test engineering role can be a really exciting opportunity because you still get to write code every day, but now your customers are developers instead of whoever your customer was before. And, lots of engineers would find it more pleasant to write code for other developers than they would find it to write code for, whatever customer is using their product. So it can be a really fun transition for people to make, and having those language barriers taken down makes that transition a lot easier.
Mm-hmm. Yeah, one of the things that always interested me about software development in the test engineering space is that I feel like most of writing software these days is creating forms and having those forms have validation and getting written to databases. And that's a pretty well solved problem at this point. So most of the UI frameworks, they have a very good canonical pattern to follow for this is how you fill out a form, this is how you write it to a database. And a whole lot of the applications that are out there, let's face it, that's probably like 80 or 90% of what they do. And so I always thought it was very interesting getting into the test engineering world, where now it's a production-worthy software system whose job is to make sure that non-production systems work properly. And when you think of it that way, it's a very interesting engineering problem, and it's a very different style of coding than what you're going to be writing if you're doing a web application with fields and forms, right?
Right. You get to tackle problems with scalability, throwing, hundreds of scenarios at the same thing. It's definitely a different problem set that can be a lot of fun, especially when you get into kind of the performance and security testing realms.
We talked about people who are on the test engineering side who want to know a little more about the development side of things. What about developers who've never really done testing? Like, how would you recommend that they get started with testing?
With developers who are trying to get up to speed with testing, I usually start with them on the unit testing side of the ball, because I think that that's something that developers inherently will understand pretty well, and it can become a fun thing for them. So you take that pattern that you see in, kind of legacy software development setups where developers create bugs and QA finds them. If you can switch somebody into doing their own unit testing in kind of a test first mentality, you're going to hit a really fun situation where the developer says, well, now that I know how to unit test, it only takes me a couple seconds to create a new unit test that tests what happens when I pass a null into this function. So now they're playing the cat and mouse game of trying to break stuff rather than waiting for QA to try to break stuff. So I think that for most developers, unit testing is a easier way to get them in the game and get them started thinking about that essential testing skill of finding edge cases. And I think test first really makes sense for that. I think that when you test last, you are trying to prove that your system works rather than trying to break your system. And that's kind of the skill that you're trying to teach those developers when you're getting them into testing is stop trying to prove that your stuff works, start trying to prove that it doesn't work. And unit tests, you're kind of teaching them the unit tests are the fastest way to prove that your system is broken, to find the way in which your system is broken. So that's really where I start with that. Once you've got a foundation there, introducing those end-to-end tests to developers can be really effective. But at least in my career, I've had somewhat limited success of getting a team of software engineers to start writing end-to-end tests without already having some experience in unit testing or integration testing, because they're so ingrained in their code base. Having them switch to thinking about this in a user-facing, browser-facing, or mobile-facing way can be a challenge.
Like, oh, it's slow and flaky. And I think a lot of that was true when you and I got started doing web testing, which was sizing the actual system under test. You're mocking a lot of things out. You're removing dependencies, and you're making sure that a small isolated method is working. An inherently faster problem to solve from a compute perspective. So yes, it is going to be faster, and end-to-end tests are going to be slower, but that doesn't mean end-to-end tests are too slow to be worth having. And then in terms of the whole flakiness thing, there are so many frameworks available now, Playwright, Cypress, newer versions of Selenium, that I think the industry's just really come a long way in terms of helping them to be more reliable. And a lot of times what I see when people say they're flaky, it's really, if we're being honest, it's not the framework that's the reason that the test is flaky. So
Yeah.
it could be setting up and tearing down the data. It could be tests that aren't written so that they can run in parallel with other tests in the same environment. It's that there's only one version of the test, but 12 versions of the code. And for some reason, we think one version of the tests running against 12 different versions of the code is going to produce the same result across all 12 versions and still be a meaningful result. So there are a lot of these reasons that people say the tests are flaky. But in reality, it can be done to get the version of the test lining up with the code, well-written tests, and have extremely reliable end-to-end tests. So
The technology is absolutely there. A lot of teams don't have the training and mentorship they need to use the technology right. Really, the biggest obstacle on these things, though, if we think about what most developers are incentivized to do, it is to deliver a feature as quickly as possible. And they receive a lot of praise from their team and from their manager for getting a feature out the door. They generally receive less praise for doing it at a super high quality level. So even though what we talked about before of shifting left on quality saves a lot of money over the long term, we still don't see executives and management often prioritizing and telling developers, I'm okay with you delivering 20% less if it's at a 20% higher quality level, because I know overall that's going to save me money in the long run. You really have to have that buy-in from everyone in the company to say, we actually do believe that shifting left will save us money in the long run. So we're willing to spend the money both in terms of time and hiring expertise to, teach people how to use the tooling. Like without that setup, you have limited results because, no developer is going to intentionally slow themselves down, in the beginning for benefits to come later. You're talking about benefits that the whole team receives, and you just look bad by delivering your thing 20% slower in the short term. So really, it's a cultural understanding that has to come in that team to say, it's okay to slow down in the short term to go faster in the long run. And that's, easier said than done.
Yeah, that reminds me of a situation with engineering managers. So we have engineering managers who listen to this show, and how often? Just ask yourself, how often have you praised your development team because there haven't been any issues in 2 to 4 weeks on that big bird? They ship a major set of functionality. Maybe it's an integration with a third-party system, and then afterwards there just aren't any issues. And then 2 weeks goes by, 4 weeks goes by. It's easy to forget to praise them for that because they're not actively working on it anymore. But I think that's the kind of thing that has to happen to remind people just how important it is. It's like if you put the time into writing the tests and you got the system to be really high quality, it went live, and nobody finds any issues with it, like that should be a thing that the team celebrates, right?
Yep.
Yeah.
And, it's, you have to think about this as an investment. You can frame it another way and say, we're going to hire 20% additional staff and we're not going to go any faster for 2 years, but we're going to get higher quality. That's a way to think about this is you're investing in quality for the future. And you have to be clear with everyone that this takes time to pay off. It's not immediate. It's weeks, it's months. If you have zero automated tests around your code, it's going to take a while before you start, seeing those bug regressions get caught in production. How long that takes depends on how much effort you're putting into it. It could be weeks, it could be months, but it's not an immediate thing. So you have to look at this as a long-term investment. But the good thing with that is that the research is there to show that it does pay off in the long run. So that's what we have to keep in mind.
Yeah. So, you and I, we worked together at Carfax where we were doing test-driven development, pair programming, extreme programming by the book. I don't know if you remember those days.
Well, yeah, I mean, it's kind of remarkable when you think back to it. This was in 2005. I was working for a company worth, $500 million that was doing, pair programming and unit testing and, test-driven development. I don't think there were a lot of companies at that time much bigger than ours that were doing that same kind of investment into unit testing. I think, it doesn't seem like it when you're there, but looking back, historically, we were really on kind of the cutting edge of some stuff.
Working there, I think we learned to appreciate a lot of the things about test automation that are kind of hard to measure. So I'm just curious from your perspective, what are some of the intangible benefits of getting testing in place that to quality?
Yeah, so the important thing to remember with testing, we don't say this enough, is that testing is about designing your software right as much as it is about, finding bugs. So for you to have a really good end-to-end testing suite, you have to have a setup where you can, tear down and set up data really fast. So that means that you know how to, delete data, you know how to restore from backups, you know how to do all these things that come in later in disaster recovery and things like that, right? So that's some important benefits. Like in order to do end-to-end testing right, you have to have scalable software, you have to have good decoupling between, data, you have to have fast deployments. All those things have to be in place. When you look beyond that to the unit testing, I've seen this over the past 20 years, and I'm sure I'll continue to see it. Unit tested code is almost always more well factored than non-unit tested code, simply because it's very difficult to unit test, large classes, large functions. If you have those nasty code smells of highly coupled items, large code blocks, you're not going to be able to unit test them. So just the fact that you are unit testing is going to encourage those better patterns. So both of those things are really big for me. Like, in order to do good testing, you have to be doing other good engineering practices that are going to pay off for you. And that's a reason why a lot of teams don't do testing. It's not because they don't want to test, it's because their foundational engineering practices aren't strong enough. So by setting that boundary for your team of saying, we're going to have tests, it challenges them to make sure they're doing the other engineering practices that come into place for that. So those are really the big benefits that I see first off.
Oh, I don't think the tests are effective. I said, well, are your customers reporting the bugs? Because, if the effect of having a good unit test in place is just that it works, but also, as you say, they're proving when it doesn't work, uh, that helps prevent the bug from ever getting created in the first place. And what's the point of the success of their QA programs based on how many bugs are getting generated? You also brought up something earlier when we were chatting about the the fact that tests help you identify more quickly where in the code the issue is taking place. Maybe you could expand on that a little bit.
Yeah. So, I mean, when you've got a good test suite, by definition, you're kind of like trying to test smaller components, right? So if you can write a end-to-end test against just one microservice instead of writing it across everything, you're going to have kind of more targeted piece. Now, you're always going to have those certain end-to-end pieces that you want to span the whole system, kind of an integration test level. But by having those automated tests in place, it lets you test more granularly and kind of narrow in on what exactly you've got. You can think about being a customer of each of the pieces. So especially if you are in a microservice environment or something like that, we've all been in those where you have the big web of microservices that it can be difficult sometimes to tell where your bug is actually coming from. So that's a key place. Like if you're trying to go into a microservice architecture and you don't plan to do some automated, API level testing, you're going to get yourself into a nightmare really quickly. So that's going to cut down your troubleshooting time immensely in my experience.
Mm-hmm. Yeah, and troubleshooting is one of those hidden costs of software development. So, I think if you were trying to measure developer productivity, for example, you have to think about like what are all of the activities that developers do? Well, they spend time reading code, trying to figure out. They spend time not just developing, but also writing tests. And so the fact that having a good set of automated tests in place can very significantly reduce that troubleshooting time. It's just going to make all your development go that much faster. And I think that's one of those things that doesn't show up when you're logging your time in Jira spent on things. Like how much of that time was trying to figure out which section of the code to update.
Yeah, I mean, long term, it can always be challenging to like measure the efficiency of a test automation initiative, because a lot of the benefits are delayed, both in terms of quality, but also that developer productivity. But if you think about, I know that if I'm working in a code base with 30% unit test coverage, I'm much slower than if I'm working in a code base with 80% test coverage. Without that safety net, it's just inherently a slower place to work. So we do see those payoffs down the road just in developer productivity. Slowing down and writing a test now is definitely going to make you a lot faster, 3 months down the road.
What do you think is kind of the sweet spot on coverage? Do you think everybody should be shooting for 100%? Is there diminishing returns as you get closer? Like where it's kind of just purely based on experience?
Yeah.
Like where would you draw the line?
Yeah. To give the broadest range, I have never worked on a code base with less than 60% coverage that I felt super comfortable with. So 60% is like my low end where I start to say this is a healthy code base. 80% is the high end where I start to say after that, you may be seeing, more limited returns. I think a lot of that depends on the language to some extent. Given the fact that refactoring and unit testing tools, I've always felt that they're a little more mature and a little easier to use in some of the big statically typed languages, Java and C#. With projects in those, I'm generally expecting a team to be able to hit the 75 or 80% mark, with a reasonable amount of effort. If you're talking about something where the test automation tools, the unit testing tools are a little less sweet, like PHP, in those I may be saying, hey, 60% is a, pretty decent spot to aim for. So there's some variability on that. And also, the type of software you're writing can matter. Mobile applications often have a higher percentage of boilerplate code in there that I sometimes don't think is worth unit testing. But with, a classic like server side Java application, I think you should be aiming for that 75% or higher. You know, that's kind of the range that I look for.
Mhm. Yeah, I do know. We tried once as an example just to get to 100% on one of the projects where I was on.
Hmm.
I guess we didn't have anything better to do. I don't know. But I do remember, like, once you got up to the 95%, like that's when you're starting to look at, okay, here's a static variable. I've got the method that's using it wrapped in a test, but I don't have the declaration statement of the static variable wrapped in a test. And it was like, okay, now is that turning that into something else? That's definitely not worth doing.
Yeah.
um,
I think the most important tool I've seen for that is picking a number and then integrating that into your continuous integration pipeline and saying, you know, we do not allow a pull request to go into our system if it pushes our test coverage below a certain level. And kind of, every 6 months or every year, upping the bar on that and saying, hey, previously we didn't allow anything to go in the code base if it pushed our test coverage below 60%. Let's go up to 65. Let's raise the bar. The actual number matters way less than the enforcement because
mm,
with the enforcement, you're saying it's not one person's job to do test coverage. You don't want to be in a situation where the senior engineers are writing, good tests, but the junior people are just kind of slinging around code and doing whatever they can to survive. You have to set that team agreement and say, this is the level we're picking. The number matters less than the discipline around it of saying, we're going to pick a number, we're going to stick with it, and we're not going to allow anybody to skate under that, except in extreme emergency.
mm. How would you do the same kind of thing with end-to-end tests where?
Those are always trickier. A couple ways I've looked at that is, kind of tracking this at a think about this at like a Jira Epic level or something like that. So if you're looking at like a high level user story, anything that takes, more than a couple days, if at the end of that, user story you spend several days on, you can't point to the end-to-end test that's going to cover the feature you just introduced, then that should be unacceptable to the team. So there's some threshold where we say, anything that qualifies as a feature or a major feature or takes more than 3 days, anything that the company has invested this much money into needs to have one or more end-to-end tests around it. So I've kind of judged it in that way in the past and said, okay, what we're doing as a team is saying we expect that 80% of our, Jira stories should have a, end-to-end tests associated to them. So it's harder to automatically test, measure that. You're working a little more on paperwork with people filling out a custom form, their ticket tracking system or something like that. But like the way I think about that is, if a company cares about a feature enough that it's willing to spend 5 to 10 days developing it, then we care about it enough that we need regression testing around it because we've spent that money and we wouldn't want to see it break. So
Mhm.
I've seen some innovative ways out there to try to measure actual coverage numerically of end-to-end tests. To some extent, I think that's a, fruitless effort. It's not ever going to necessarily get you there, but I think it's better to measure something like an end-to-end test on a feature level because that's really what you're doing. You're measuring what the user experience is in terms of the testing. So just saying this feature that the user experiences needs to have tests around it.
Mm. Yeah, one of the activities I like to do with clients is go through user stories and then talk about what are the acceptance criteria for your user story, but then take it one step further and say, okay, should this acceptance criteria be a unit test, an integration test, or an end-to-end test? And I think that's a really good exercise to go through as a team because it kind of helps establish, for each feature or for each user story, if you're following something testing pyramid like, you're going to have a certain number of unit tests, you're going to have a certain number of integration tests that's probably less, and you're going to have a certain number of end-to-end tests, which is probably even less than that. And I think, going on a feature by feature basis and going on a story by story basis and periodically just saying, okay, here's our acceptance criteria. How would you test each one of these as a team? Kind of helps establish that team norm around what should be a unit test versus an integration versus an end to end. And then the other thing around that is I like to periodically grab a random story that was just completed by the team and take a look at that story and say, okay, was the content of the story at a sufficient level of detail? Because that's always one of the things that when people start writing stories, they're like, okay, should they be where you kind of just have that conversation as a team of like, okay, was this too much detail, not enough detail? And I like to do that same thing with testing. So you can grab a story and you can go through that exercise of, okay, should this be an end-to-end test, an integration test, or a unit test? And then you can say, okay, so where are they, right?
Mm-hmm.
Did we do them? Did we not do them? And that kind of, I think, reinforces with the team of like, yes, we really care about getting good, solid testing in place. But we're also not going to just assume like every story must have all three or the ticket doesn't get moved.
That reminds me of a team I walked into probably 10 years ago. There was a manual tester on that team and knew the product really well. But the team was kind of outstaffed, right? There was a situation where there were too many developers and only one manual tester. So we were bottlenecking all the time on, releasing software from that. So what we did in that situation, we took that manual tester and we said, your job is no longer to test people's software for them, but you have an incredibly important job skill, which is knowing what to test. So your job now is to tell the developers what to test, and they have to do the testing. So that actually created an interesting situation where you had one person deciding, what needed to be tested about the software, and then another person deciding whether that test should be a unit test, an integration test, a end-to-end test, and really just making that best technical decision for where in the test pyramid that would go.
Mm-hmm.
And that was, very effective because the developer obviously wanted to put the stuff as a unit test whenever possible. But with that system, they weren't allowed just to say, oh, because something's hard to test at the unit level, I'm going to ignore it. They had a list of what they had to test. So that kind of forced them to build into that pyramid concept all on their own and, write end-to-end tests where necessary and kind of fill in the gaps with unit tests for, whatever they could do. So that same kind of pattern of, having it be a team decision of what should be an end-to-end test, what should be a unit test, what needs to be a manual test. We actually got to, in that situation, the kind of unconventional method, but that same concept you're talking about of, that team buy-in of where in the pyramid things go is really, really important.
Responsible for bringing in the initial teams. Let's say you're hiring a team of developers for a new project.
Yeah. So you're always looking for, if you can find people who have testing experience, that's going to do your job for you because they already know the value. But that's hard to find sometimes. So what you're looking for is people who are kind of, for lack of a better term, independent thinkers, people who will be able to step back from their code and say, I'm going to try to find ways to break this thing and make it not work instead of just saying, I'm going to prove that it does work. So in that situation, what you're really looking for is kind of, personality and low ego more than pure technical skill, right? You want somebody who is, not going to just sling some code and then say, I'm sure this works because I wrote it and I'm great. You're looking for somebody who, has a little bit of skepticism about their own code. One way you can show that skepticism is by unit testing your own stuff, but I think you can tell in interviews, whether people have that or not. I always like technical interviews where I ask people to whiteboard out a solution for something, because that thought process and the way they talk about it and the way whether they leave themselves some breathing room to be proven wrong or to consider other options is super important. I think that, hiring a developer without actually having them work through a problem on a whiteboard with, pseudocode or something sets you up for, failure if you don't do that step. So getting somebody who has an opinion but is willing to change it easily is really important. I had a coworker who used to always talk about strong opinions loosely held. And I think that's kind of good frame for developers that I like. I want them to come in with an opinion about what they think is right, but I want them to be able to change it quickly without getting personally upset or, being too resistant to change. So that's really kind of the thing I look for there. We're talking about team composition. You'd love if you had unlimited money to bring on a person with test engineer experience right away. That's usually a luxury you don't have. I think that by the time you get to kind of that full scrum team, the 7 to 9 developer range, by the time I'm there, I want somebody who has done test automation experience in the past, kind of at the end-to-end level to kind of lead some of those experts. I think you may be able to get the first couple developers on your team just with unit testing, but by the time you've got a product out there with real customers on it, and by the time you've got, 4 or 5 developers on the team, you start looking for someone with that end-to-end automation experience to help keep your quality level up.
I'm pretty sure that our audience found this a very entertaining and interesting conversation. So
Hey, thanks a lot, Chris. Bye.